Hi, I'm Matt Lewis with Hagerty. In today's DIY, we're going to be talking about automotive fuses, where they are, how to test them, and what to expect. In every car, you're going to find fuses, and these fuses are designed to protect the electrical circuit that they're connected to. The way in which they do this is they are the weak link in the circuit. If something goes bad, shorts out, this is the first point of failure in your circuit, as opposed to a wire overheating, catching on fire, or damaging some electrical component. In order to test fuses today, I'm going to be using our handy dandy multimeter. For this, we're going to change the setting over to DC voltage at 20 volts. So one of the ways you can test a fuse is with voltage while it's still in the car. So I've hooked my bench battery up to this fuse holder here, and we can see with the negative terminal hooked to the negative of the battery, our output wire is at 13 volts. Now, this is a fairly common automotive fuse. They may come in different sizes, but this particular blade style fuse also gives us two terminals on top of the fuse. This is another area you can test the fuse without removing it from the holder. And what you would do is take your positive and test this little spot. Again, we're at 13.4. And you can come over here and test this side, 13.4. And what that means is the electricity is flowing from our battery through the fuse and out to our lead here. This is where you would find a light bulb or a motor or your radio hooked up. Now, if this fuse was bad and still in the car, you may read voltage on this side and nothing on this side. And what that means is there's no longer a connection between these 2 points in your fuse. That signifies a bad fuse. Another way you can test the fuse if it's not in the fuse holder is with our ohm or continuity setting. So we'll go ahead and switch this over on our multimeter. Again, make sure that our leads are hooked up correctly. And go ahead and hook one terminal up to one side and the other terminal up to the other. Here we can see we're well below 1 ohm, which means these two terminals are connected internally. That's the sign of a good fuse. If this fuse was bad, it would read open just like that, as if you weren't connecting the two. Lastly, with a fuse like this, this plastic is translucent, so you can actually see in to the fusible link that's inside of this fuse. And you can do a visual inspection to say, is this burnt? Does it look like there's any issues there? No, this fuse looks good. So that is a quick visual inspection if you don't have any tools on you. Now, with automotive fuses like this blade fuse, there's a couple of telltale signs as to what you actually have. The color of it is going to denote what the amperage capacity of the fuse is, as well as the number 10 on top here. If your circuit exceeds 10 amp for any given amount of time, this fuse will fail. You don't want to move up in amperage size if your fuses start blowing. There's another problem. You're going to want to figure out what that other problem is. So don't go from a 10 to a 15 if you keep blowing 10s. Hunt down the problem that you're actually having, because the wire isn't designed for that circuit to be using more amperage, and it could heat up and cause issues. So now I know we have a bad fuse because I went ahead and blew this one just to show what it would look like. And if you do a visual inspection between the two, you can actually see there is no connection from side to side. It's melted back. If we put it in our fuse holder, we can use our multimeter again to check voltage on it. So we check this side of the circuit that our light or whatever it would be is connected to. We have nothing. We move in and check this top post of the fuse. This side has nothing. The other side does have voltage, and that's because this post on the fuse is hooked directly to the battery. A bad fuse will read voltage on the battery side and no voltage on the load side. And like we did before, if we take it out and measure continuity with our ohm setting, we can see there is no continuity. Our meter doesn't change at all, measuring between the two blades of the blade fuse. So that means these two are no longer connected. The fuse has failed, or functioned properly and is now dead. All right, so now that we've looked at a fuse on a bench, let's go over to our Volkswagen Beetle and take a look at what the fuses are in this car and test them out and see how they look. So here we are inside of our classic Beetle. You'll notice these fuses are quite a bit different than the ones I had on the bench. The bench fuse was called a blade fuse. This is a ceramic fuse. This is pretty common in older European vehicles to see this kind of fuse. Just like the blade fuse, you do have a visual inspection. Is there a connection here? And you can check them the same way with your voltage setting on your multimeter. So the first thing you're going to want to do is with your ground lead, you're going to want to find somewhere to ground it on the vehicle. There's a couple places you could look, but the chassis of the car or the body of the car always acts as the ground. So we have a bolt here holding up the steering column. We've got a bolt here holding up the power outlet, and actually I know that the inside of these power outlets here, the inside of these power outlets also are the ground on the outside. For the sake of making this easy, I'm just going to hold it up against our steering column bolt. Now it is worth noting that these fuses may not have power all the time. This white one here is a constant fuse, meaning it always has power. This next one in, this blue one, doesn't have any power with the key off. But if I turn our key on, now we see it has power on the fuse. And this is what's considered an ignition circuit, meaning that it's off when the car is off and it's on while the car is on. A circuit that turns on with the key, a good example would be your radio or say your heater. The fuel pump only wants to run when the key's on. Those sorts of things are under what's called switched power or ignition power. Something that would run under constant power, like we see with that white fuse, would maybe be your headlights. It doesn't matter if the key's on or off, the headlights always work. Same with your interior lights. If you have lights on the inside of the car, you don't want to have the key on for the lights to turn on when you open the door. Those types of circuits are on a constant power circuit, meaning they always are connected to the battery regardless of where the key is. So when you go to replace a bad fuse, make sure you match up the current load of the fuse to the circuit that you're replacing it in. And then for this kind of a vehicle, it is a spring-loaded fuse. So you put one end down, run the other end up, and these are not as user-friendly as a blade fuse, but you want to get it just like that. So the bottom's in this hole of this spring-loaded side, and the top's in the hole of this stationary side. If you don't know where the fuse box is for your car, go ahead and open your owner's manual. It's going to say exactly where all the fuse boxes are located within your car. If you don't have an owner's manual, go ahead and look under the hood. That's a common location for fuses, as well as under the dash like it was in this Volkswagen. Well, I hope this simple explanation of fuses and how to test them in your automobile was helpful. If you have any questions or comments, please leave them below and hit the subscribe button so you never miss another video.